So I've gone quiet. We'll start then. So, hi, I'm Keith. I'm going to be doing a talk on DLL hijacking. So, a little bit about me. Everyone seems to do this slide, so I'm Keith Learmonth. I am another Rabbit ethical hacker. I'm in the fourth and final year. Hint, hint. And yeah, people usually take this time to sort of say their experience and what they're good at. So I'm an advanced Googler, then I switch things off and on again. Usually works. So, oh yeah, there's just my Twitter and a plug for the Aberte hackers. So, DLLs, it stands for Dynamic Link Library File. They're all over Windows, pretty much the backbone of the Windows operating system. They sound complex, but they're basically glorified executables. It is just a collection of code, different functions. The only difference is there is no entry point to a DLL. They have to be called by other applications. But the path to a DLL is going to be different on every computer. So what if an application can't find the DLL it's looking for? There is a set path that an application will look through to try and find the DLL it needs. So it starts off in, there is a registry value called known DLLs, which is just a list of directories that we'll look in first. Then there is the application folder. So for PowerPoint, it would go into the Microsoft Office folder in program files on the C drive. Then it will look through the current directory. I mean, this is before Windows XP Service Pack 2, which put in some mitigations against this. But it would look through the current folder where you've opened the calling application from. Then it looks through the system folders, so System32, syswow64, and then system. And then it looks in the actual Windows folder on the C drive. So, annoyingly, you've got System32, which is the 64-bit folder, and you've got syswow64, which is the 32-bit folder. Windows. Yeah, some of you might be able to see the problem already with putting the current directory so far up the path. But apparently it's not a bug, it is a feature. It is supposed to be like that. So DLL hijacking is essentially putting a DLL of your own creation further up in the path than where it will find the one it is looking for. So it'll look in the current directory before System32. So if I just put a DLL with the same name as one it's looking for in the current directory, it'll find that first and say, this must be the right one, and not even bother looking for the proper one in System32. So you can just plop a DLL that'll set up a reverse shell and then just go away and wait for someone to click on the file. And that's it. So where could you infect a machine? The most common one is on a network share. So you're at a company, you have access to a network share, you put in, say, a spreadsheet called salaries.xls, and you hide a DLL, and you just put a DLL in the same folder. Since DLLs are hidden by default, the majority of users looking at that network share, there will just be an XLS document. When you click on it, the DLL runs, and you win. Any sort of archive files, so you can put a zip file with a DLL in it and salaries.xls, and when they extract it, it extracts the DLL at the same time into whatever directory they've chosen to extract files into. So there's many different ways to get the DLL into the search path. So I mean, you could just place a lot of different DLLs for a lot of different applications into popular torrent sites, wait for people to download the torrents, wait for people to torrent the files, and I mean, you can, if you put a video and then a DLL for every single media player you know, you've pretty much got any attack there. So, a demo. Fingers crossed. Drag it across. Oh, this way. That's why it was working. So, yeah, I decided to take a video rather than trying to do a live demo because they don't work. Okay, so here, if I can get the mouse to work. Yes, there's a folder called malicious folder. And all that's in here at the moment is a PDF. So when I open it, it's a very good PDF. It's my document. So it just opens fine there. There is nothing in the DLL. There's no attack in the PDF itself. So what do I do next? Yeah. So now we need to find an appropriate DLL for the attack. So I'm sure most of you will have used Process Monitor at some point. It is just a simple program that records every action by the processes running on the machine. So yes, I've got a filter here, so it will only show the process calls that are by foxitreader.exe, and the path ends in DLL. No, I've paused for you to look at it, so. So you can see it's recording them at the moment, and when Foxit Reader starts up, you've got all the different calls it's doing there, all the different DLLs it's calling. So, yes, so you can see here, it's a better demonstration. You've got, it's trying to find netutils.dll. It's a bit small, I can't make it any bigger, sorry. But you can see that it's looking in program files, Foxit software, Foxit Reader, which is the application folder, and it can't find it. So you can see it's then gone to look in the current directory. It's gone to look in malicious folders, but it can't find it. And then it looks into the system folder, and it does find it there. I'm genuinely not sure what I did here. Okay. I had a list of things to do in this demo, and I think this is me reading it at the moment. So just to create a DLL, it is really simple. MSF Venom in Kali Linux has the feature of creating malicious DLLs itself. So you just put MSF Venom. Of course, it's executing calculator. What else? Yes, and you just make it output as a DLL and it does it all for you. It's very simple. And to get past any sort of checks in for the network share, you can encode it and it will execute as normal. So the DLL I decided to use is called cryptsp.dll, which is something to do with the cryptography functions in Windows. It's used in many, many applications. So I just copy it over into the malicious folder. And the normal user would see it as hidden because, if I remember right, DLLs are hidden by default on Windows. So this is what it would look like to the standard user. And when you click on it, it just opens Calculator. Very simply. And if you look at the processes running, you can see Foxit Reader has run, it has tried to execute the DLL and just run Calculator instead. So that's enough there. Where's the mouse gone? There it is. There we are. So, what have Windows done? Microsoft swiftly implemented mitigations. There was a Securi bulletin put up about it in August of 2010. The first papers that were written about it were internally in the NSA in 1998. The first external papers were in 1999, and the first big exploits using it was probably the Ninja worm in 2000. So yeah, swiftly implemented mitigations. So what were their mitigations? Disable the web client and block ports 139 and 445, which is pretty much mitigating against a DDoS attack by switching everything off. And I've cited it there as well. That is genuinely what they've recommended. This is the impact of what doing that would have. Services that could be impacted, which would be impacted, would be anything using Samba, anything with mail slots, servers, group policies, DFS, computer browsers, the fax, the indexing service, RPC, and the management server. Oh, and the performance log as well. And you wouldn't be able to fax anything, which is a great loss. Yeah, Microsoft are gonna Microsoft. So they did eventually make some actual attempts. First one was Safe DLL Search Mode, which was introduced in Service Pack 2 of Windows XP. All it does is changes the search order. So before the current directory would come in there, all they have done is just moved the current directory to the end of it and then just pushed everything along. It fixes most of the basic DLL hijacking flaws, but there are some problems. MFC42log.dll is a localization file for the translation of something in Windows, but the thing is, it's only present in Windows systems that aren't running in English US, whatever that is. It's not a thing. But yeah, it only exists in Windows instances that are not using English, because it's a translation DLL. So basically, it will look for, applications will look for this, but it won't find it. So it will say, okay, I'll need to look in the application folder. It's not going to find it. It's going to look in the system folder. It isn't going to find it. It's going to look in the Windows folder. It isn't going to find it. If it doesn't find it in current, then it says, okay, it must be running in English. So it just stays in English. But I can write a malicious DLL, call it mfc42.log, and put it in the current folder. And even with the mitigations, it'll find it in the current folder and say, okay, I've just got to run this. Yeah, and another thing, Windows at the same time implemented a function called setDLL directory, which allows you to place directories in here. So you can actually put your own directories in if you needed to use this feature for whatever reason. I cannot think of any. Yeah, just adds directories to the search path. And the very main thing is, the most Windows thing I can think of, there's a difference between null and empty strings for putting in when you put it in this function. If you put in an empty string, which is just, would be quotations with nothing in them, it will remove the current directory from the search path entirely. It won't look for it at all. If you don't put anything in, it stops safe DLL search mode working. So you can either mitigate against it or completely remove all the mitigations against it, and it's the difference between putting nothing in and putting in empty. So when this didn't really work, they made the catchily titled current working directory illegal in DLL search. And this was in July 2010. At the same time they released the security bulletin, the Swift security bulletin. It's a registry value that has 4 different legal values. So 0 is it switched off, it just stays on the default search path. 1 will remove the current working directory when you're in a WebDAV share, and 2 removes it while in a remote share. So it mitigates against DLL hijacking in network shares. Or you can put FF, which always removes the current working directory no matter where you are in Windows. This does solve pretty much all the issues, but it can cause problems with applications. For instance, programs that involve forking processes. The child process often needs to use DLLs, and it needs to use the current working directory to find that DLL. It's above me. I don't know why. It just does crash things occasionally. Also, these two only block hijacking attacks from the remote shares. So I mean, what I said about the zip files is still an attack. It still can be done. So, really, how bad is it? It's a very targeted attack. It's not your MS-08-067 or WordPress vulnerabilities where you set up a server to scan the entire internet and exploit everything vulnerable it finds. You need to have a knowledge of the target system, and since someone has to click on the file, there's an element of social engineering in it as well. It's, rather than as an attack on its own, it's more useful in conjunction with other attacks. It's very, very useful in maintaining your access to a machine that you've got into by another way. So say you have got into a machine through MS-08-067 or whatever, you can use DLL hijacking attacks to make sure you stay on that machine. And yes, as per tradition, Apple have stolen. Surprise, surprise. So DLL hijacking is also a thing. It's surprisingly recent. I mean, DLL hijacking has been around since 1998, I said. This is only, the first papers about it came out last year, as soon as I started looking into it. This guy decided to present a talk 2 weeks after I first started looking at this. So yeah, it's a lot more complex due to the way OS X loads their libraries. It has a thing called the dynamic loader, which basically maps all the DLLs it needs into the application and then executes rather than just go as it needs it. So it finds the dilib, loads the dilib, links it, and then enacts it. And I haven't looked into this too much due to time issues, but there are things called weak and strong libraries. Strong libraries will crash a program if it cannot find it. Weak libraries are like MFC42 lock, where if it doesn't find it, it deals with it fine and keeps going. DLL hijacking is in weak libraries. If it cannot find it where it's supposed to be, it looks through RPath, which is something the developer of the application sets up. So while DLL hijacking is mainly an issue on Windows and not so much for the developer, DLL hijacking is more an issue on how an application is developed rather than a problem with Macs. And yes, in theory, any operating system using shared objects or dynamic libraries or any sort of shared library is theoretically vulnerable, which includes Linux in some ways. Again, mainly due to developer error rather than an operating system error. For example, there are two debugging tools. They're ostensibly debugging, but we know that developers don't like to keep their debugging tools as debugging tools. Where LD library path, where the user can define their own search path. They just write their own search path and Linux says, okay, that's where I'm going to look. And this is a configuration file that contains the default search path. So if you wanted to maintain persistence, you could edit this file once you're in a machine. Actually, I will go to give you an idea of how big a problem this is. Let's actually have a look at this security. Actually, I think I've got it on my video. There we are. So I'll keep going with this. Yes, here is the security bulletin. This is the bit where it says switch everything off. But it also contains a list of all of the Microsoft security bulletins that involved DLL hijacking. And you can see that from 2010, there's one in 2010. And I mean, the latest one was in May 13th, 2014. So you've got one in there. There we are. So go back a second there. There are MS-10, 87, 93, 94, 95, 96, 97, MS-11, 01, 3, 15, 16, 17, 23, 25. One of their knowledge base articles, 55, 59, 71, 73, 75, 76, 85, 99, 94. And that's in 1 year alone. I calculated this, and 16% of the Microsoft Security Bulletin updates were due to DLL hijacking in that 1 year. And then it moves on to 2012, which is a similar story. What if I clicked on there? Yeah. There were 100 security bulletins, and 16 of them were DLL hijacking. And I don't know how I've still got a minute here. Let's have a look at what I've done. Yeah, here's the most recent one, which is a DLL hijacking vulnerability in the Chinese translation system of Microsoft Office. So this is everywhere, and I mean, it allows remote code execution. It is almost ubiquitous on Windows. And they still seem to think it isn't a problem. What else have I done? Oh yeah, This is actually my favourite one. MS11-001, which was a DLL hijacking vulnerability in the backup manager. So essentially, if you did manage to get access to a system, you can put a malicious DLL in with the backup files, at which point, if the target realizes they've been pwned and decides to try and revert to a backup, it just executes the DLL instead of doing anything they want, instead of reverting to the backup. And the greatest thing is, if you do manage to put it in, when they try and run the backup, it runs a system. So I think that is everything there. If I can find the maps again. When I set up two monitors, it's always when I go off to the left that it goes to the other screen, and this one it's on the right, so I've been confused the entire time. So